Okay. All right. Well, thank you folks for joining. So I have the pleasure of introducing Dr. Adam Rainear. So he's an assistant professor, although soon to be associate. He's put his tenure package in this semester at Westchester University in Pennsylvania. Dr. Rainear did his undergraduate work in meteorology and journalism and media studies at Rutgers. So I imagine some folks have some overlap with him. He received his master's and PhD in communication from the University of Connecticut, which is where I know Adam from. We did our graduate work together. His research is focused on examining communication during times of weather crises with a particular interest in mediated risk communication using social media and new technologies. His recent work is focused on understanding if the race and sex of broadcast meteorologists impacts viewer credibility, trust, and information retention. He's also done research investigating if emergency weather communication delivered by a robot impacts subsequent weather responses. His talk today is titled Leveraging Physical and Social Sciences in Meteorology for the 21st Century Challenges. Please join me in welcoming Dr. Rainear to Stony Brook.
Thank you, Christine. I appreciate it. Thank you so much for the invite. I'm a very big fan of Stony Brook and all the work that's done at Stony Brook, because there's a true interdisciplinary collaboration, I think, between physical and social science there that a lot of universities don't engage in at such a strong high level. I thought I'd start off with a little bit of a joke, because when I was leaving UConn, Westchester thing was really hard to explain people, because everybody thinks Westchester County, Westchester, New York, being the most populous county outside the city. But actually, we're on the western half of Chester County, Pennsylvania, which is where Westchester comes from. Two words, not one. A little bit different, but we're still Northeast, still many similarities, I think. Just a very brief little bit about me. I'm an assistant professor of media and culture. I'm in the communication and media department here at Westchester University. I got my BS in meteorology at Rutgers University, alongside of getting a Bachelor in Arts in journalism. If you can't figure it out from that combination, I did want to be a TV meteorologist to start, like many people in the field of weather kind of desire when they get started. But things really switched during my what I'll call my most impactful weather event in Hurricane Sandy. So I'm from Southern New Jersey originally, born and raised there. I've lived in New Jersey, except my 5 years in Connecticut, lived in New Jersey my whole life. And so when Sandy happened, I really switched my gears pretty significantly, and I focused less on physical science, and I really was less interested in being on TV and thinking about the research and the physical science processes. No more QG Omega and all that fun stuff and Calc 4 and everything. And I wanted to switch to what are humans doing with the weather information, and thinking about that kind of broadly. And so I pivoted into the true social science of communication instead of being in journalism. My first weather event that I can recall that drew me to the field of weather, everybody's got one. Mine was Hurricane Floyd, because it was the first weather event that we canceled school for that wasn't a snowstorm. So we had 2 preventative days of school canceled for what was Tropical Storm Floyd at the time, which was just so cool as a 7 or 8-year-old kid or whatever I was. Why is the weather going to be so bad that we aren't going to school, but it's not snowing outside? Kind of weird. Get stay home and play video games. My favorite weather systems, tropical systems and blizzards, the best, of course. Being able to kind of study social science in the field of meteorology, it's really, really a cool space to be in. Risk and crisis communication is a very, very established field of communication. It explores all kinds of different topics, risks across varying areas, whether it's a health risk, an environmental risk, a science-based risk, a technology-based risk, whatever. But the goal usually for risk and crisis communication is almost always to limit harm and then ultimately prevent future crises from occurring if we have the ability to do so. Most of the research in this space is post hoc analysis, which can be problematic. You need a disaster to happen to then go and study it, which isn't necessarily the best situation for research to formulate, develop, and inform us in the future. So how can an organization or an agency respond? How do practitioners respond? How the general public respond to some kind of crisis? And we can look at that from a variety of different angles. I think weather is arguably the best risk or crisis to study. I know I'm biased, but I understand that. I think it is this way because we all have a perspective and an experience with weather, whether it's experiencing the sunny days we step outside to every single day, whether it's living through Category 3 hurricanes because we're on the Gulf Coast. It doesn't matter. Everybody has some individual experience with weather. There's a lacking body of risk communication research specifically applied to the field of meteorology compared to some other fields. Now, it's significantly growing. It's certainly strong. Places like Stony Brook do it a great service when you're combining atmospheric and oceanic sciences with communication and anthropology and sociology and all these different spaces. And you even have centers for communicating science. Like the research in this field is certainly growing, but there are still significant gaps. We also have this varying levels of individual experience that people have with weather. So those of us who live on Long Island might have a different set of experiences with weather than those of us who grew up in Norman, those of us who lived in Key West, so on and so forth. And this affects our preparation. It affects what we know about weather. It affects the shortcuts we might think about when somebody tells us something about weather. Today's a high-risk tornado day, so I know I need to stay close to home to be close to the shelter or whatever, kind of shortcuts we make. So we are faced with this battle of like making people feel like the weather is always serious, but never too serious that they can't do things. Very similar to health, like making people feel like you keep doing bad behaviors, it'll ultimately affect your health, but you can still live your life within moderation is kind of how we usually communicate those things to people. So one of my earliest research publications kind of addressed this idea and thinking about how can we collect better and more meaningful data in the field of risk and crisis communication that can be applied and utilized going forward. So in true social science, we almost always desire a randomized sample or some kind of trial to draw these large representative conclusions. We're testing a drug or we're testing some kind of manipulation we're delivering people. But does a randomized trial really tell us that much in a risk and crisis context? Because risks and crises often don't affect people randomly. They often affect people who are already pre-affected with other dispositions anyway. You can also just be honest about your sample. If you collect a crappy sample and your data is going to be based around a crappy sample, you acknowledge that in your limitations section. So again, the targeting of a population may actually be more beneficial or more useful in this context of risk and crisis research, which differs a little bit from trying to acquire a large-scale randomized sample. I've done some work on wildfires where we've actually searched out zip codes that people were affected. The wildfire was reasonably affected that area enough that we could use that zip code and target that area for better chance to reach an affected population. But then once we've collected the data, maybe we collect some that's in an affected area, we collect some that's not in an affected area. We collect a lot of data in these situations. User-generated content is one that I'll talk about a little bit today. It's stuff that's already out there, stuff that's already existing. It doesn't require an IRB, which for a lot of social science researchers, that's really beneficial. It spares you a lot of time and issues and sometimes frustration in trying to get your research approved by the university. It also removes some of the issues with participant-researcher relationships that do exist sometimes. Like sometimes we just have to reach out to and interview the people who were affected as the researcher ourselves, but that can lead to some biases. So if you can't really tell, I'm passionate about this field, improving and getting better, but also passionate about bringing the physical aspects to the social aspects of meteorology so that we are creating and generating research which is really strong and really informative for improving the future communication of weather. I don't think this topic will be all that new to many people. So a while back, the Weather Channel started naming winter storms. I think it was around 2012 or 2013. And this is an area of research which really drew me full on into communication and full on into social science, because I saw some deficiencies and I saw some flaws that we weren't working out as a field in the proper kind of way. So the Weather Channel started naming winter storms using their own criteria. And there was a lot of debate at the AMS, the American Meteorological Society convention, about is this beneficial or is this problematic for the general public? It goes against a government agency doing it. It's not NOAA, it's not the NWS, it's not anybody like that. It's a private media organization who are oftentimes competing against other private media organizations and so on and so forth. But what I found really weird was in this conversation, the scientists themselves were all falling into their own biases. The physical scientists really argued hard that this is really a marketing gimmick. Like the Weather Channel is trying to get people to watch their channel and view their stuff. And the social scientists argued, well, yeah, we might not know that yet, but there is some potential utility with naming. We've named tropical systems for decades. You know, it does serve some utility. We know the importance of hashtags on social media. But nobody did any research. Nobody came to the table with like quantified data that said, yes, people feel this way, or no, people feel this way about names. And I found that interesting. Like us as a very rigorous scientific field, we weren't doing the research on it. And so one of my first grad school studies about this was looking at, do names matter? And people really criticized the Weather Channel because a lot of their names drew on mythological names rather than the common European style names that we see delivered for tropical systems. So Hurricane Andrew or Bill or something like that versus a mythological name like Zealous or Nemo. So this practice isn't abnormal. It's just the way we maybe applied this practice seems a little more abnormal. And from that, it allows the public to like make fun of or make light of some serious information. A pretty impactful winter storm that I believe led to blizzard conditions in the heart of New England, becoming a Pixar fish and like being memeified and jokeified and gamified, which in this case isn't all that bad. Like it's funny, it's cute, it's gimmicky, but it's not all that detrimental. But sometimes it's worse. Like sometimes the names that we choose legitimately lead to an impact that distracts from the actual communication about the weather. So when your name, Winter Storm Janice, leads to you standing in front of the J repeatedly in your large scale graphics, and it looks like Winter Storm Anus over and over and over and over, like people are obviously going to make fun of that and make light of the situation when we might want them to be talking more seriously about what to do or how to prepare or where to get your bread and milk from or whatever. So I just posed some research questions about this, and I was interested in a couple of different things. Does the Weather Channel lose credibility because they're using this naming list? Does severity or susceptibility to a winter storm maybe adjust how people feel about the naming strategy or create perceptions of the storm based on the naming strategy, I guess I should say. And then the third one, is there any positive or negative reactions here? And so this was my stimuli. So the stimuli here was a mock tweet very similar to what you'd see emerging from the Weather Channel. And the only difference that occurred was this hashtag Bill here, the name, which would deviate between Bill, Zealous, or if you saw the control condition, it would be an unnamed storm. And I was kind of surprised that the findings that emerged here, but generally speaking, it doesn't really seem like people care all that much. People are not so distracted by the name that it leads to lower perceptions of credibility of the organization disseminating the name. People are not so distracted by the name that they are finding the storm less severe, or they're feeling like they're more and less susceptible because of this or something along those lines. And so we at least had some quantifiable data that said, well, nothing's really happening here. And so maybe there are arguments for the Weather Channel not deviating from a government agency or engaging in a different practice like this. But at the same time, it doesn't seem to be harming the general population. It doesn't seem to be harming the general public in any way by choosing one name over the other, or choosing to name a storm versus using the control and not naming a storm, which was something we had seen up to this point. My research isn't the only research out there. I'm aware of this, and I don't think it's the most important research out there in a lot of spaces and cases. And so I want to talk about other areas of these fields being merged together that I think are really important, and I think are going to be things that we continue to explore and discuss and talk about at future seminars like this one, and 10 years from now at AMS, and 20 years from now at AMS. Like, what are the conversations we're having? One conversation that we're having that's not totally new is the conversation about, are the colors we use to communicate the best colors to represent what we're trying to communicate? So are we utilizing the color best for people to perceive some kind of threat, some kind of impact, some kind of negative connotation that we might place in this color, or maybe not necessarily negative, but forewarning connotation that we might place in this color? And then do we use the same color so repetitiously across different hazards that maybe the meaning doesn't exactly land the same for people. So like, how do you warn people about a really, really, really strong snowstorm? We use a deeper and deeper and deeper and deeper blue a lot of times, or a purple or some shade of indigo or violet or whatever. But when we talk about our severe rainstorms or tornadoes or tropical systems, that color is red. And so thinking about the differences there and how we draw people towards the extremes or not draw people towards the extremes. And this isn't that new. Like, we've been considering how we use our color in weather displays for a pretty long time now. We've had a discussion in the field, and now as we start to think more about processing and ability and visualizations and different things along those lines, in addition to having way more information than we've probably had before, we're reapproaching this conversation a little bit different. So I thought this was pretty funny because they talked about how we have new information sources like Doppler radar and wind profilers, which aren't really all that new anymore. But and there was the challenge here was like, how do we bring all these novel forms of information that we're communicating to people, like showing them a radar for some of the first times on television or whatever? How do we apply the color so that it means something to them? And how do the codes we use apply the color ultimately is what's happening that means something to them and is going to show this is what it symbolized, this is what it represents. We've learned, and this has happened in all kinds of different aspects of social science and meteorology, that we might not be doing things in the most effective way. And that's okay. Like, it's good to learn because it means your research is uncovering things that we may not have understood as well previously. And so there are some who argue we should move away from the color palettes of the red, the green, the blue, the RGB color model, and move towards this hue, chroma, luminance, HCl color model that better represents kind of how the brain and the eyes perceive human color dimensions. And so I wanted to pull a couple of maps just to show you what this kind of looks like out of that paper. And between A and B, they've applied one step of their color correction analysis, moving from RGB to moving towards the HCl, but they did not apply it to the color. They're doing it through grayscale there. But if you compare A through C through E, this is what they're getting at. They're starting to revamp their product using the HCl-based color map, and it becomes a little less harsh on the eyes and is still able to draw the eye towards some of what is the most important information, or in this case, what looks like the extremes that we're trying to potentially draw the eye to. But it doesn't just have to be precipitation. We can talk about it in terms of equivalent potential temperature and geopotential height. So I remember these maps, and I always found these maps very confusing because the colors were really, really, really extreme in a lot of them. They didn't utilize warm and cold colors in the same traditional sense as many of the other maps we look at. And so not only were they harder to understand because they're different types of maps at different levels, but also adding in the fact of like, this color scheme is very different than one I'm familiarized with and using often, and so on and so forth. And so they've made this shift for this specific European analysis for the equivalent potential temperature, making that HCl change between the top one, the old color model, versus the bottom one here in the new color model. And it's not all visual. I think that's the coolest thing about the weather. We're able to combine the visual and the language-based elements together. We can show people and we can tell people simultaneously what's going on, and people have a lot of times have a basis to draw on because weather's so visual. You see it oftentimes, and many times we determine what the weather is just by looking outside at what's occurring. When we talk about language, though, there's two areas that we really should think about and we really should focus on. The first being the types of information that we use in the message. So how are we using our language, specifically English language, I guess we would say here, to deliver the message? And then the second piece is English language even the best language to deliver the message in? Because as I'll show in a second, like for many of us, that's not the case. It's not the most useful way. Or trying to take something in English and translate it, drop it into Google Translate or whatever, and send it to Spanish-speaking folks, like that translation oftentimes doesn't match up, or there's dialect missing, or subtleties of the language that aren't picked up by a translation service. And we need a human to do that, or we need an individual to understand some nuance about the language there. if you're unfamiliar, I just wanted to be obscure with my translation there on the last one. The bottom one's Gaelic, so the Irish spoken language. I just thought I'd pick something obscure and different. So the earliest look that I was interested in with language difference is, do we communicate hazard and outrage differently by using imperative versus declarative language? So imperative language tells people what to do behaviorally when we're talking about the weather, like move away from the window now, get into the basement, get into your storm shelter, stay off the roads. Literally, here is what you should do to be in a safe space during this event. Declarative language just declares something. It provides a statement, an information, fact, whatever. It will rain today. There will be 10 inches of rain. It's going to be sunny, but it doesn't tell you anything behaviorally. We know from prior research that the combination of the two is usually the most desired message structure, because it provides somebody some baseline information to make a decision off of, and then also gives them the efficacy, the feeling that they can make the behavioral decision or make the behavior because you told them what to do. So we, this warning agency, think you should get into the basement because the tornado is on its way there. Sounds like they're giving me a logical reason for why and telling me what I can do. Seems very straightforward. But when you leave one of those out, it allows people to try and fill in the gaps themselves. I think I should go in the basement because of X, Y, and Z about the tornado, or I know there's a tornado, but what do I do now? Go outside and take pictures, go into the basement. I'm not really sure where to draw my line here. So I investigated this amongst the student population. I was interested in two different factors here: the language structure, the imperative and declarative, and then how far away the risk appeared to folks. So was it severe thunderstorms that are happening tomorrow, or is it a tropical system that's a couple of days out, and I might not really need to be thinking about my behavioral decision right now? I didn't find a lot of differences. There weren't a lot of differences in how students in this sample were perceiving the message, whether it was about the event type, whether it was about the type of message that they got, so whether they got the imperative message, the declarative message, or the both message. And this was consistent across both conditions. There was no difference in whether somebody was willing to find shelter or willing to move within a different space of their home for either of these conditions, depending on what they were and how they were delivered. So the language that we choose to use, I know Jeanette Sutton does a lot of work with this, who I believe is now at SUNY Albany, who was previously at the University of Kentucky. She does a lot of work with this, and she's come up with kind of a formula or a structure that they suggest to offices of emergency management, practitioners, and the like, of how your message should be structured to make sure it hits a couple of the key points. It's clear, it's straightforward, and then it'll be received in the best possible manner. It also has to be in the language you speak to be received. I mean, this seems pretty straightforward, but when we start talking about places like New York City or the city of Philadelphia, for example, where it's very diverse and not everybody is speaking English language, we have to rethink about how we're delivering that message. And if we only rely on forecasters who are on Spanish-speaking channels and we disseminate the message to them and hope that they get it out, or we as a government, we as a warning agency, we as NOAA and the NWS, we take more ownership of this and we start to investigate and explore how can we get better at communicating to those who speak language, communicating to those who speak or are from a different area or something like that. So even regionally across the United States and in the English language, this is a problem. So the AP test withholds certain terms regionally because we don't refer to things as the same thing across the United States. So like what's a curb here in the Northeast may not be the same thing in the Midwest, or may not be the same thing in the Pacific Midwest, or sorry, the Pacific Northwest, or they may refer to it as something totally different and wouldn't understand what we were talking about when we use that term. Joseph is doing some awesome work centered around Hispanic and Latino populations and Spanish-speaking folks. And it's so important for a variety of reasons. The first and foremost is it's the fastest growing demographic in the United States. 1 in 5 Americans are of Hispanic or Latino population or descent. And 71% of these individuals primarily speak Spanish at home. So from this, you could roughly deduce that like something around 12 to 15-ish% of the population is probably speaking primarily Spanish at home and probably acquiring their information, weather, science, political news, whatever it might be, using the language that they're most familiar with. And so we should be aware of that and cognizant of that and think, are we communicating things out? Are we translating things out in an appropriate and best manner? And in many instances, we're not. I wasn't even aware of this until I met Joe and I kind of saw some of these presentations that like there are so many differences across one language, across Spanish language, for example, that change how you would translate a simplistic word into another word. And that has implications for folks. And so these translations aren't always equal. And we have to be aware of that either at the market level and thinking about how our meteorologists on television are warning folks and communicating with folks, or take a step back and think about it at the NOAA NWS level, which is kind of what we've really started to do. So now we have graphics that do communicate things in Spanish and give people action depending on what type of hazard or risk is impending that they might be faced with. And so many of these things are disseminated out ahead of time, obviously, so that people are aware and have some semblance of what to do if that situation does arise. This is an example graphic created by the Spanish outreach team, which was started through various local NWS offices, plus kind of run through NOAA. And I think it's really cool. I think it's a really awesome application of thinking about how can we better serve populations here in the United States. We did it in New York City as well. The Know Your Zone campaign, another great example of this that really is, if you think about it, it's centered in campaign formation and it's centered in strategic communication. Like this is a really strong strategic communication example because you're trying to reach all these different groups who are doing things very different. And it takes a pretty strong strategy to ensure you can actually target and reach those groups. There have been similar campaigns to Know Your Zone. I think Turn Around, Don't Drown is a common one that we're all familiar with. And oftentimes they do emerge after some kind of large-scale disaster. So what we found with Hurricane Sandy in New York City was people didn't know their flood zone. And thus, when they were told, you're in flood zone A or B or 1 or 2 or whatever it might be, and you need to evacuate, or if you're in A or B, you need to evacuate, they wouldn't know. They didn't have a starting point to even decide whether they needed to make the behavior or not. So the slogan refers to the flood zone you reside in within the city or generally anywhere based on the FEMA flood zone information. And the background here is just to generate that awareness for any time there's an impending coastal risk. And we've had this instance occur a few times since Sandy where there's been a significant enough coastal risk that we're worried about coastal flooding and other types of flooding as well. So the information is provided, but it still does require individual decision-making once the information is communicated, unless there's something like a mandatory evacuation where we're knocking on doors. In this specific case, it was targeted at New York City residents across all the boroughs, and the population was super willing because coming out of Sandy 2 years after Hurricane Sandy, the impacts were still present in our minds, and we realized if this happens again or something similar happens, we need to be prepared and we need to better understand what to do. So they presented this in 13 different languages because New York City is so diverse, and there's an argument that those languages reached enough of a threshold to actually create the campaign for them. What also is cool is they didn't present it the same exact way in all 5 boroughs, which I think is really smart because if you know anything about the city, all 5 boroughs are not the same. People from Manhattan are very different from people in Brooklyn. Like I think we know this through a lot of different contexts. We know this through our popular media and how it's communicated. We see it through news coverage. If you get New York City media markets and you watch that news coverage, we can see differences in how the boroughs handle themselves, how the boroughs deal with these things. The goal here was to show people where you could go evacuation center wise if you needed to. So there was less of a concern of travel or when MTA was shut down and closures and things like that. You could figure out how to get to your zone earlier without having to worry about You could figure out your plan to getting to your zone earlier, and also account for the fact that if some of those things along the way weren't working, like MTA, for example, you would be able to account for that because you were prepared ahead of time and not figuring it out in the moment as the disaster is bearing down on you. We do really good, simple slogans in weather, like know your zone is smart. I think it's great. Turn around, don't drown is awesome. Like we have these catchy slogans. We just have to make sure that the benefits are obvious to folks for not partaking in that risky behavior. I think we're seeing this with turn around, don't drown right now. I think we're having a lot of emphasis on stop driving through floodwaters as a whole field, as the field of meteorology, because we've seen so many deaths lately specific to cars and people getting swept away in floodwaters. And we're making it known that here's what's going to happen. It only takes this much water for your car to get lifted off the ground. And there are going to be really, really bad ramifications if you make attempts to, drive through those flooded waters or not evacuate in a flood situation. So I'll pivot now, and I'll think a little bit about the future. And I hope that this bleeds into what I intend on leaving some time in the Q&A section at the end. So we'll just discuss and hear different perspectives about where we think the field of meteorology will go. But I think it's going to continue to grow. It's going to continue to improve, and it's going to continue to remain extremely useful. If you're familiar with NWS at all, we've seen impact-based forecasting and impact-based decision-making making a lot of waves recently, and showing that here's what the impacts will be and how people can prepare for those being just as beneficial for folks as telling them what the weather specific impact will be or what the weather specific criteria will be. Christine alluded to my robotics research for me. I'm not going to talk a ton about my robotics research just because it's not all about weather, but there is one study in particular that I'd like to just highlight. And then also thinking about technologies that are close to robotics, but we don't actually think of them as true robots, like a chatbot, for example, which is probably way more applicable to the field of meteorology. But I do think in the next, I don't know how many years, we will see a space where we're going to reach more people in affected locations using these types of unmanned systems. We're already doing it in certain situations like shooting situations or bomb situations from a police standpoint. We're seeing it in really risky rescue situations along cliff sides and stuff where we can't get actual rescuers to. It's going to become more commonplace as the tools become better. But the question is, how will people respond to these tools as we start to deploy them and as we start to disseminate them? And there are two arguments. The argument is if you're in a life or death situation and you're really close to the bad thing, any information should be helpful and allowing you to make a decision to hopefully get yourself out of that situation. But if that only information is coming from a robot, do you have questions about it? Do you have questions about who delivered it? You have questions about if it came from a human in the first place. And so you really start to get wrapped up in like this technological distraction instead of focusing on what I need to do to get out of a risky situation or help myself and save myself. I ran a really cool study at UConn where I brought students, very, very, very susceptible students. We all know how our students are. We brought students into the UConn Video Game and Media Effects Lab and had them sit over near those closed windows you'll see in the back of the image there. And then once they sat down, we delivered them a mock National Weather Service severe thunderstorm warning. And the warning came from either one of two folks. It came from me as a lab confederate, as a human warning another human, or a robot, as you see there on the screen, wheeled into the room and disseminated the same exact warning to these students. At the end of each warning, we asked the students to move away from the window for their safety and protection. So they moved over to these couches and chairs to continue the rest of the study. And then students would complete by finishing the survey. And it was really cool just to witness this study, like not even thinking about the research and the statistics and the findings yet, but just seeing how people interact with novel technology is so cool to experience. There would be people who would come into the lab and start talking to the robot as if it was another human, just totally normal, not baffled by it at all. There would be some people who legitimately looked like they were going to drop out of the study the moment they saw the robot, and they wanted to turn around, like walk out of the room and go back home because they were freaked out. And so when we like use these novel forms of technology, we just need to ensure that we aren't distracting people from the important part of the message, which is usually going to be the behavior and the weather. In this case, we really did distract people significantly. So they retained, let me see if I can find the number. Here we go. At the end, they had a factual retention question, and those who were delivered the face-to-face message remembered about a half of question answer more than those who were delivered the robotic condition. So they answered 10 true or false questions about the warning, like what type of warning was it, which towns were mentioned it was going to affect, yada, yada, stock NWS warning language. And those who were in that robotic condition remembered a half a question less, which was a significant difference than those who were in the face-to-face condition. That's pretty important. That's pretty powerful. And that may be dependent on how novel the technology is. And this may be an extreme example. But in the same vein, if we're deploying new technologies all the time as technology advances at a more and more rapid rate, we have to be cognizant of these things and we have to be aware of these things. Sometimes it could be something like a Twitter bot. The rise of artificial intelligence is just going to increase the number of things that we encounter that auto-disseminate information, unless Elon Musk ruins the rest of that for us, auto-disseminating information. We have chatbots, we have other types of bots that can interact with you. The weather space is one where this could potentially succeed because a lot of information is automatically pushed out in some cases. And so if people start to become aware that their information is not coming from a human so much as a computer, that may be problematic. And the findings that we write about in our qualitative study really suggest that people don't like technology. It caught me off guard. I wasn't expecting a tablet on a stick. They attribute gender or sex to the robot, depending on what they perceive it to be without any cues telling them what it is or things like that, which I think is interesting. Finding it unique that a robot is able to do this when you're so used to seeing a news anchor give the weather. I don't really see this as the future so much as I see other applications that are more useful, but still an interesting area to study, excuse me. And then I want to talk a little bit about machine learning, AI, advanced computing, things like that, because I know forecast models are so dependent on many of these things, and we don't often think about them in a social science context, but they're becoming really, really applicable and useful in a social science context. So I know a colleague, Brett Robertson, who's down at the University of South Carolina, him and his team put together a deep learning, I don't know if the appropriate term is, I guess some type of model that was able to classify images of disaster impacts and then determine how they fit into certain categories, and then matched it up to human coders and found that the computer was doing so at an equal rate, an equally successful rate to the humans who were classifying that information. And so if we can leverage some of this computing power to help us learn something about disasters and help us learn in a real-time fashion about disasters, that's really impactful. Not everything is going to be about the models themselves when we think about our high computing power going forward. We can leverage this and utilize this to study our social media communication. We can leverage this and understand this to classify images, to take practices that aren't easy and make them a little bit easier and a little less time consuming for us. So in another paper, they actually combined an old school method with a new school method and used the classification system alongside of in-depth interviewing to see if those comparisons were working and if the images could reveal patterns that people were kind of revealing through the way they talked about their volunteering, working behind the scenes to coordinate what was going on in this disaster case. So even though we're using these new tools and we're relying on these new tools, we're still supplementing them with old school tools, arguably the oldest one around in interviewing, and combining them to give us a more rigorous picture. Many of the things I think we're trying to address are the biases. How do we address the biases that humans have when they're acquiring weather information? This is usually referred to as a heuristic, a shortcut that we will use when we're making a decision. Heuristics are not new. This is not a novel idea or a brand new idea that has emerged. It's not even all that new to the field of weather. You see the article here by Chuck that's on the screen. When we're forecasting the weather, NWS, whoever, private organizations, we often rely on heuristics to help us make quick snap judgments or decisions. I'd argue seeing a storm forming and crossing over something like the 40-70 line off the coast of our area is a heuristic for where the rain snow line might set up. It's a rough shortcut, but we know that like there are a million other factors that could potentially influence that would cause the rain line to move in, rain snow line to be closer to the coast, whatever. We do this. We know localized heuristics about our region, about the Sound, about South Jersey and the Pine Barrens, whatever it might be, that we'll rely on and know the Pine Barrens get 3 degrees colder because it's all pine trees. And I can rely on this and I can apply this to whatever the model might be spitting out or making that extra human-based judgment. Where it's problematic, though, is in high severity instances and in high uncertainty instances, relying on these heuristics may not always be a good thing. Or we may rely on the wrong shortcuts to make decisions. Also, as we become more and more polarized, we're making heuristic decisions based on our political beliefs and our ideologies, and that can also have implications. You have to think that these ideologies, these heuristics, these shortcuts that we make when we're making decisions, they impact so many areas of our lives. They impact our purchasing decisions, our media considerations. They impact whether or not you believe in conspiracy theories. They're certainly impacting our science information consumption. I think you see this a lot with climate change information consumption. And some biases are worse than others. Some heuristics are helpful. Some heuristics are not so helpful. So if a storm name reveals that it does actually help people find information on Twitter because it helps them realize it's raised to a level of importance, and now I need to go and find more information, that seems beneficial. But there are all kinds of heuristics now. Like colors can serve as heuristic. Seeing the breaking news banner over and over and over can serve as a heuristic. This is one of my least favorite ones, the weather alert days that the media often run with on a day that it looks like there's a subtle chance for rain, and all of a sudden we now need to lead with the weather every 5 seconds and remind people it's going to rain tomorrow, and like oversaturate this idea. Originally, this would have been a heuristic. Like if the news feels like the weather is so important for me, I'm going to pay attention to it now. But it's so sensationalized and overdone that we can't even rely on a heuristic like this anymore. And some of them kind of fall by the wayside and don't necessarily work the same way. And so we'd argue, like, where does that heuristic come into play? Like, what category makes me go, okay, today is a severe weather alert day, and now I need to pay attention. And then when we change a scale like this, which is a whole nother conversation, a whole nother discussion, how does that impact why people pay attention to it? I'd argue that this is important because everybody's getting their weather from the smartphone. And I think that's only going to get worse and worse and worse as the group that is now young continues to get older and older and older. Min Fan did a really good study. I think it was in BAMS. Yeah, it was in BAMS in 2018, where he did an assessment from a couple of different universities of how college students were using their smartphone mobile weather applications. And I'm sure many of us have feelings about smartphone weather mobile applications because you see really pretty cool looking information, but oftentimes it's a one point in time snapshot about what the weather will be. And people carry that forward for 24 hours. They carry it forward for, this represents the full day, even though if I open this up in an hour, it might look totally different. So this is what they're getting. It's useful, but it's very, very limited. And people are relying on it more and more and more. 81% of the respondents in their study said that they use a weather app at least once a day. These are the future older demographics as these folks get older and older and older. And I imagine the numbers will continue to go up for mobile phones as the new young generation moves into college or something replaces smartphones. I don't know what's next. And people really just want an easy to use app, easy to use, easy to understand. So something about that idea of simplicity and the shortcuts is really what people are desiring. My least favorite piece that they want from the forecast is that they want the percentage of precipitation, but then they're going to not understand it anyway. So I don't know if that's the best thing. That in itself is a great example of a heuristic because people see it, utilize it, but they aren't understanding it. And we know that people don't truly understand what percentage of precipitation means to them specifically. And that's problematic because they're taking a shortcut and leveraging and using it, but not doing so accurately. I am going to, let me see, give me 1 second. I'm just going to see where I am in my slideshow, and then I'm going to leave some time for Q&A. So I'm just going to cut out one chunk of my slideshow and kind of leave it off. So we have about 15 minutes to discuss. The goal here, I think, when we're combining the physical and the social aspects of meteorology is where can our research help inform society? Like that is the main goal. It's the goal of the physical scientists who are trying to forecast and better understand the weather so that people can make strong decisions from it. It's the main goal of the social scientists who are helping us understand what is the best way to craft a message to get somebody to act. But also thinking about the fact that these two jobs in themselves are two of the most stressful fields by themselves. Communicating science is hard, and it's often left to non-experts to do so. And the field of meteorology is a really stressful field as well, whether it's on television, whether it's working 12-hour shifts for NWS, no matter what it is a stressful space to work in. And when you combine these two together, in addition to the fact that people's lives can depend on the information you're kind of delivering to them, it leads us to a space that we can create research that is going to be really informative and really helpful for society. I didn't look at who joined the call before I made my slides pop up, but if there are students out there, the one thing I want to highlight that I think sometimes gets lost in all of your physical science training is you will have some kind of secondary skill that you're strong at, whether it's writing, whether it's computer coding, whether it's public speaking, philosophical ideas. For some of us, it's art. Like some meteorologists are actually good at art. Their brains work both ways. Leverage that skill, use that skill in meteorology, in social science, and weave it together, because there are so many spaces where we could use folks who are strong in both aspects, the actual science behind meteorology and the social science, the art, the humanity behind some other field that you can combine with them together. That's where I think the field will be going in the future. And I think that's the way you can kind of best set up yourself to be prepared for that. So I didn't put in a question slide. That was a stupid move, but I'll just stop sharing and make that my endpoint. And I'd love to have questions, thoughts, conversations. I think this is a cool collection of people and a cool collection of departments and groups that are brought together for talks like this. So I'm really appreciative of the invite. Thank you.
Thanks, Adam. So I'm happy to moderate folks, but I would say go ahead, unmute yourself. Comments, questions, responses. Brian, please go ahead.
Hi, Adam.
Hello.
Very interesting presentation. So I was soaking it all in here. Now, Christine and I have been working with the Weather Service on similar sort of topics, and I think we might even have one or two on the call here. Dave Riddell, in fact, I see his name. So I was soaking up some of the stats, especially the ones like weather source information and how people get that. And one thing we've been struggling with our project is that sort of question, especially warning information. And then the other caveat is that in New York City, we have all these vulnerable populations in various areas of Queens and so forth, especially those that were hit with Hurricane Ida. And so the question becomes, sort of, and we're trying to figure this out. I'm just curious about your 2 cents about where these folks might be getting that warning information. And the concern is obviously technology may not be the best source. Because they just may not have a smartphone and that sort of thing. So I'm just curious, what's your perception, or has there been recent work in this area that you're familiar with?
I haven't seen any published work, but I've seen, so anybody here is on Twitter/X, you may be familiar with the weather communication hashtag group, whatever, that always seems to discuss some of the topics that kind of emerge in our field before they seem to land in the research space. And this is a topic that has sort of come up loosely about where are people getting information that seems like it's so different from what we deliver, like from the NWS, or even what the NWS is delivering to media outlets. And then obviously that's going to have subtle little differences by just chain of communication and everything like that. But what we're finding, and I think what we're seeing, is there is this subset of stuff that goes viral, particularly on TikTok, but I'm sure it's the case on X, Twitter, whatever, and other social media as well, that I would call misinformation or weather inaccurate information or something like that. And what's really crazy is TikTok is so powerful because people can gain such a following and such a virality so quickly that we can't really like account for that misinformation in real time or like combat it side by side. It's going to take off way quicker than we're able to like correct it, because that's not what we're focused on. Like, we're focused on the next model run and then the next forecast update and then making sure all of our partners get information. And then side by side to that, there's this like virality of misinformation that has 1 million views on TikTok. And it's like, how do you address both of those aspects side by side? That's hard. And whose job is it to address that? Is it NOAA NWS, who is obviously short-staffed? They have 1 million things to do already. They can barely manage the social media they have to manage and like all those problems. And or is it like trying to be better, more literate consumers of media and understand like, no, you can't just accept the first thing with 1 million views because you think it's the most popular. You have to actually be able to return to logical and reasonable sources. I mean, I teach media literacy on the side. Our media literacy in this country is absolutely terrible. And it bleeds into our technology literacy too. And I think there is a large community of people who are getting that information that just gets to them first on something like TikTok because it was viral or it reached them.
Great. Thank you.
Yeah, thank you. Good, great question. I'm glad to see those partnerships are happening. I'm trying to do mine with Mount Holly, and it's been hard because I think like 10 people retired from there in the last 2 or 3 years. And so everybody is new and my age and people I went to college with and stuff like that, but they're also doing 5,000 trainings and new things at once. So it's been a little hard to dive in, but I've seen NWS is hiring social scientists all over. So it's great to see that.
Thanks, Brian. Other questions? Yeah, Michael, please.
Yeah, hi, Adam. Great talk. I was wondering if you could, you're probably aware of this, but at the Storm Prediction Center, there's this ongoing discussion about their convective outlooks and their use of the words to describe larger threats for severe storms. So it goes from marginal to slight to enhanced to moderate to high. And a lot of people have, they've polled their students and, the students would say, I don't rank marginal, slight, enhanced the way that others do. And then the SPC says, well, we give them numbers now. So marginal is 1, slight is 2, enhanced is 3, and colors. So marginal is green, slight is yellow, enhanced is orange. And then there's sort of like a further argument, which is these convective outlooks are sort of quasi for the public, but more for other meteorologists. I wanted to put you on the spot and see what you thought about that communication.
Yeah, this actually, so I went to an integrated warning training hosted by the NWS last month, I think it was, in Delaware, hosted by Mount Holly. And this was a big topic of discussion. There's 2 areas I think it's really problematic. One is everything on the map is always green. And so that green category really doesn't hold a lot of weight. Like, I understand the purpose meteorologically myself, but the general public, I don't think understands that purpose. But then you're right, maybe we don't need to be communicating that to the general public the same way. I don't have an immense problem with the argument of like, do we use a qualitative term versus do we use a quantitative term? Because I think people find them beneficial both ways, but I agree. The first three qualitative terms are particularly problematic. Like the word marginal and like how it related to what they used to use even is confusing, I think, because they either added one or skipped one or something. Something's like slightly tweaked from how they used it before that causes a lot of confusion between the difference between the old model and the new model. I don't think they've personally arrived at what will be the longest lasting, like kind of final model before we stop like adjusting it and either move to something new or whatever. But I don't personally love it going out to the public as much as it does. The news organizations love it now, probably because WSI takes the map and makes it right there for you in the screen. How many high risks in the Northeast have busted in the last, I mean, there have been instances where high risks have been really centralized, but then they've been wider communicated to a group that isn't necessarily affected. And, you know, I think when we start to highlight how not often the high risks are in a certain location like this or like that or something like that, and then we highlight like we're missing on forecasts maybe not as often as people, like there's this misperception of how often we miss on the forecast that people don't grapple with either. I don't know, I have a roundabout answer I guess to your question of like, I don't love the system. I didn't love that we changed to a system that's so similar to the old system, and I think it has a lot of refinement and improvement before it continues to go forward. But you also see a similar argument with the cone of uncertainty, even though we see that as really useful, really strong, you know, it falls within less than 50 miles of landfalling so often, but others have tested more interactive cones that work better with the brain and processing, but they're so advanced that I don't know if we need to make the switch. So I'm glad we consider these questions more nowadays, but I don't particularly love the direction it's gone in with the SPC category and the terms themselves.
Yeah, I think so. I think the change was that they added enhanced and just where they put the enhanced and also just to follow up, you know, when I lived in Oklahoma, there was one of the news stations was notorious for taking that Outlook data and then renaming it. So it's not, so you mentioned like, okay, you know, WSI might just take it and make a map out of it, but then some of them will take the map and then change the names.
Yep. Or even the color. I've seen people use like subtly different, like it's instead of a red, it's now pink or, you know, whatever. And it's like that difference is like people are aware of that difference, I think, enough when they compare across different sources in the same DMA or whatever. So I think it's a great point. Yeah.
Yeah, it's kind of a mess. All right, I appreciate your comments.
Yeah, no, thanks. That's a great question.
Joseph, go ahead.
Hi, Adam. Thank you very much for your talk. It was very interesting. You know, I've started to become in this space, which is very interesting, as working with Christine and Brian in this interdisciplinary meteorology, social science area. Building off of the last question, how do we get people to like make a change? You know, like if we have something that we've used for 30 odd years, you know, especially this cone of uncertainty, as you mentioned, but that's something that I personally am passionate about changing. How do we all of a sudden change something and get people to be like, oh, I know what this is. It was this, now it's this, rather than just like, you know, changing a color slightly that people are aware of, but it's like, what else is different? You know, like this, how do you get people to be on board with that or not so jarred by it, kind of a thing?
When you find the answer to this question, let me know, because it is, I think the field of weather is so resistant to change. And I think most of us are probably aware of this. We probably acknowledge it. All of our models are based in Fortran. Like, you know, like we are aware of some of the deficiencies of like how laggard our field can be. But at the same time, we are also in many instances rigorous scientists who understand when something points in a specific direction. I think we've made great attempts to collaborate interdisciplinary in better fashion. I've reviewed grants for NOAA in recent years that have brought in like groups like Stony Brook, you know, the OUs of the world, where you have a center that's focusing on this social science topic and a center of advanced computing that's doing physical science. And then you got math and statistics, and you have all these folks together to create a really rigorous science project. And the results are going to be really strong, really believable because of that process and following through with that interdisciplinary process. So I think the main thing is to continue working that way in this field. Like if you look at the cone is certainly a meteorological thing. We have, you know, requirements, thresholds, whatever that we meet for categories, for moving the cone, for the track, for the spaghetti plots, for this and that. But how somebody receives that, how somebody processes that, how somebody processes a change, that's like a psychological question. And so you need a psychologist probably to understand the brain and how it's processing that information. If we're adding in color to that, you know, we might be bringing in somebody else, and so on and so forth. So I think continuing to work in this space, the field's improving before our eyes. Like I'm sure if we take the snapshot of today and compared it to 30 years back, almost all of us would say the field is more efficient, it works better, and it works more collaboratively together and with other entities outside of true physical meteorology, physical science meteorology. And I think that just has to continue to improve. I don't think there's a golden answer to like what gets people to change. It's probably topical dependent. And also sometimes it's just there might not be how something is proposed may also influence whether or not it's going to change. So the way the Weather Channel went about proposing the storm name situation, NOAA was never going to adopt winter storm names, probably partially as an artifact of just how the Weather Channel went on their own, created the system, proposed it to the National Weather Service, or proposed it to NOAA, who was like, no thanks, and then just continued to go forward anyway. Like that doesn't create a good working relationship really between those entities. So some things are just dead on arrival because they either come from the top down as a change, or somebody proposed it the wrong kind of pathway upward, and it's not going to be considered seriously. So I think it's improving. I think it's getting better. I think continuing to work in this space will continue to see improvements, but it is a work in progress.
Yeah. Going back to the naming winter storms, it's so much easier for me, and I would imagine for other people that it's easier to remember a storm name rather than like, oh, this was December whatever of this year. You know, like I don't even remember what years these happened, but I know the name and I remember the impact, and I remember. So
I think what's interesting about that is it triggers people so bad, but in the most monumental storms, we just name them after the fact anyway. Snowmageddon, Snowpocalypse, the blizzard of '93, the storm of the century. Like we just name them these boring generic names that we have to like add the century in to know what we're referring to know which blizzard of which century it is, instead of like what you're saying, just using a name that would make us go, oh, that's Andrew. I remember that's 1992 and the destruction that did. So like, I think you bring up a good point, and I think there is something that can be said for the idea that's there. But again, like the way it was done definitely did not approach the whole field and the whole community, I think, the best way.
Yeah. All right. Thank you.
Yeah. Thank you.
I know we're a little bit over time here, but Edmund has a question, and Adam, if you've got some time, I'm happy to stick around, folks, as you need to leave. But
I'm fine.
Yeah, Edmund, please.
Hi, very interesting talk. I just want to follow up on the previous discussion. It seems that people are naming or categorizing more and more things now. For example, atmospheric rivers, Cat 1, Cat 2, Cat 3. They sound similar to hurricanes, but if you look at it carefully, they say that, oh well, Cat 1 can be beneficial more than annoying because it brings water, and then Cat 2 can be both, and then Cat 3 is bad most of the time, and things like that. So it seems to me that you're using the same kind of of terminology as a
Mhm.
hurricane to name something very different, and even for something that may be beneficial, which seems to me to be confusing things a lot about the
Yeah.
terminology.
Yeah, so that's a very good point. And I think what the name can do is it can highlight something for somebody that they may not otherwise have noticed. So like call their attention to it. So in the case of atmospheric rivers, you're right. And I think people, particularly those on the West Coast, probably have some understanding of what Pineapple Express is, because that's a terminology that's called out of atmospheric rivers that the media or news or whatever may refer to and may utilize over and over and over. And they can say, oh, I see how that situates into like my weather knowledge about what is happening. I agree though. We are naming more and more and more things. Like we saw something kind of work and kind of like have some utility, and it worked really well on social media because you could track your impressions and you can track how many people are engaging with a topic and sharing a topic and stuff really, really easily. But when the name becomes not necessarily so clear, or it's not one word, it's 3 words, or it's a phrase or something like that, or we're just overusing the same term improperly or incorrectly or unfortunately, I would argue it is a deficiency. I think one area where you see this is bombogenesis and the polar vortex. So the media has taken both of those terms, and every time there is a cold air rush from Canada, we're now inundated with the polar vortex. We're inundated with the polar vortex, and like people like, you could ask people to recall this term and they would remember it from news, but is it actually helping people better understand the weather and better understand what's happening in that process? And I think that balance of sensationalizing versus being useful is a tough balance to fall between. And to go back to those weather alert days, I think that's what's happening right there. Like if the news keeps doing that sensational weather alert day, it doesn't mean anything. And after a while, we stop paying attention to it. But if they do it once a year, like a high risk in New York or a high risk in New England or something like that, like the SPC, then we're like, oh, wow, this happens once every 3 years, once every 2 years. I need to pay attention. So yeah, I agree. I think it's becoming saturated a little bit too much. But if we're just going to name things post hoc anyway, then maybe it is useful still. I'm not sure where when I originally started this, I loved the idea. The longer I've talked about this, the less I love the idea. But it's worked really well in Europe, and the European agencies have found a lot of success with their collaborations across Ireland, UK, England, in communicating storms that are affecting countries all over the place. So there is some utility somewhere, but I don't have an answer, I guess.
Thank you.
Thank you.
Any other questions here? Sorry, my cat is apparently very interested. Okay. All right. Well, then round of applause. Adam, thank you so much for joining us. I think probably based on the conversation, there's a lot of overlap. So we will certainly be in touch about potential collaborations. And I think, yeah,
awesome.
Perfect combination of physical and social science. Certainly aspirational for me. So
awesome. Thank you. I appreciate it. It's been great to meet everybody. I appreciate the awesome questions too.
Cool. All right. Have a good rest of your day, folks.
Thank you.